Okay, so this video we're going to cover the Xnormal workflow for extracting your texture maps from your base mesh. So first of all, some of the things that we have to take care of is the fact that the mesh has to have UVs. So the previous video where I was talking about laying out the UVs inside of Maya, that would be kind of a progressive video after that, kind of taking it from Maya into Zbrush and then essentially extracting those maps. Now we have talked about extracting the maps inside of Maya, or rather Zbrush. Under the texture window, we can go create and then export the polypanes or some of the masking features and also the normals. So what I want to do today is actually talk about how we can use a different software to extract the normal maps and the other types of map details. In my personal opinion, I find that the normal map extraction inside of Zbrush does an okay job. It's not perfect, it's not super clean. It does a reasonably good job. If you were to compare that with something like Xnormal or Turtle or other kind of extraction software, they're more dedicated to this kind of scenario. So usually you would expect to get more better results if you obviously know the software. So instead of using this, what I'm going to do is export the low poly mesh for our current character. So using exports, I'm going to export this as my low poly female base, LP for low poly. I'm going to save that out, and then we also want to export the highest definition one. So I'm going to go up to the highest subdivision, and I will then, level 4 in this case. It's only 400,000 polys, but there's a lot of sculpting details that we can extract that from our high mesh. So for this, we actually don't need to have UVs for the high poly mesh, and the reason why I'm mentioning this is if you were to export an OBJ from your current mesh at, let's say, 2 or 3 million polys out of Zbrush, it will take a very long time to extract, and the file will probably be around 800 megs to 1.8 gigs sometimes. So for that reason, it's better for you to then delete the high polygon UVs, and the mesh will essentially reduce at least by half in size, and it's a lot easier to manage if you had to import that into another software. So for that reason, I'm just going to hit delete, even though this is going to be a temporary delete. Export, and then choose my female base HP and export that as well. So now that I have the two meshes, I can then launch the Xnormal software, and I'm going to launch that, bring that into view, and this is the actual software interface. It's very simplified. In my opinion, it's like super old school. There's no fancy user interface of sorts, because they were not really focusing on that for the sake of texture extraction. The algorithms and the stuff happening behind the scenes is quite advanced, and it does a really good job at getting some really nice textures. So once you launch it, you're going to have to go to the first tab and work your way down until you get to the generate maps. So I'm going to load my high poly mesh first. So I'm going to click on high definition, and then in here you can right click and say add mesh. So this would then go and load a place where you can choose your mesh. So I'm going to choose my female base HP. I'm going to open that up, and it does support quite a few different formats. So it supports OBJs, FBX, all those kind of formats. So it's quite compatible with most 3D applications. So once you've loaded that in, you'll see that there's some options here. If you scroll to the right, there's some options for scale, there's some options for vertex colors, there's some options for smoothing, whether you want to use the exported normals or if you want to override that with average normals, and so on and so forth. We'll address them as we go along if we need to change them accordingly. And you can load in as many of those meshes, high poly meshes, into your high definition meshes window, and those would essentially be extracted to their low poly mesh base. So you'll see the first one is going to essentially bake to the first one in the low poly definition window. So in our case, we're only working with two meshes. We're not really going to be working with other clothing bits and so on. So for that case, we're going to keep it quite simple. So under the low definition, we pretty much do exactly the same thing. I'm going to go to add mesh. I'm going to go to my female base LP, load that in. And the first thing that you will notice is this one has an additional max frontal ray distance and max rear ray distance. This is to do with the calculation how far the ray will be shot from outside the surface towards the inner mesh or towards the low poly mesh to figure out the depth before it does the actual calculation for the normals and all the other kind of map extractions. So what kind of values should we be using? You can try and type in a max value and a min value and trying to figure out what's the value that works best for it, but you might have to end up doing multiple tests to figure it out. So they've implemented a feature called the ray distance calculator that figures that out for you. So for us to have access to that, we need to go to the actual tools, and then there's some fancy features in here. The one that we're actually looking for is this one. So I'm going to click on that. It's going to bring up another window, and you're going to choose a low poly, and you're going to hit go. And this will essentially process the two different meshes. I'm just checking something. Radius is less than 2 units. Please scale up the base. Okay. So what it's telling us here is it would actually work better if we physically scale up both the high poly and the low poly for the rays to be a little bit more accurate. So I'm just going to stop this, close that, go back to over here, and you can see there's a default mesh scale. So I'm going to jump this up to maybe something like 10, and you want to repeat that for both the low poly and for the high poly, and this will scale it up so it's a little bit more manageable for the ray distance calculator. It's still giving me that error. You could also go and export these two meshes in your other 3D application, scale it up, and then freeze transform them, and then bring it into your application. But let's see if we can get some workable values. So it's doing some calculation over here, and you can see it's 5 seconds currently. And usually I leave this for approximately 30 seconds to a minute. You don't really have to wait like 10 minutes or anything. This will keep going to infinity, so you have to actually stop it when you want to stop it. And how I know when I want to stop something or not is looking at the front max and rear max distance, and you'll see that if these values are staying static, if they're not physically changing anymore, they've reached their maximum and minimum value. So you don't have to kind of wait for it to eventually, you know, do something. So after about a minute, you're going to hit stop, and you're going to say copy results. So it takes the values from the max and min front ray distance values, and it transfers that automatically into the low poly mesh definition over there and over there. So how would you have ever figured out to use that particular value for this? It would take you a very, very long time to try and get the exact values. Usually if you were to do it manually, you'll have to kind of estimate a starting point and an end point. If that doesn't work, you're going to reduce or make that half, and then essentially work it down until you get to your closest value. But honestly, I don't think it's necessary to do that if you can just use the ray calculator. Right, the next thing that is worth mentioning is that there is a use cage feature. Most 3D applications have this thing. Some of the applications call it not cages, but rather envelopes. So think of it this way: if you actually have a card going into an envelope, the envelope wraps it so it protects it essentially. So whatever is inside is technically protected. So the same principle applies here. What the cage does is essentially wrapping a volume around the mesh between the high poly and the low poly that says whenever the calculation is being processed, it should not go beyond the actual bounding box of the cage. Any values beyond that will be terminated. So where this would be useful is parts like the fingers, where you have a lot of overlapping between the fingers, where the ray might be shot through one finger, hitting another finger, hitting another finger, and then the texture will essentially be projected on the inner sides of those parts. So that's obviously an issue. So the cage essentially reduces a lot of that overlapping or stretching or weird projections that might be an issue. So we'll address that when we get to it. I'm going to keep it full to the most basic settings first, and then we'll add them up as we go along. So there's, you can see, you can load in your external cage and so on. I think the mesh scale feature that the ray calculator was talking about is this scale and not this one, but regardless of that, that doesn't matter. We can still override that using that setting. And then everything else, we don't have to change any of this unless we get into the tiling of the UVs. Then this part will become very important. Okay, so pretty much high poly and low poly is set. Now we choose the maps that we want to extract, something like the normal maps, the specular maps, the cavity maps, curvature maps, so on and so forth. So under the baking options, we will choose an output path. So this would obviously be the place where you want to save out your textures. So I'm going to go to my desktop and I'm going to quickly create a temporary bakes folder, and this is where I'll be saving the maps. You can see that you have different file formats. You can save out JPEGs, you can save out PNGs, Targas, so there's pretty much all your file formats are there. For the sake of this, I typically save out a TIFF file format. It is one of the larger file formats, but it supports 16-bit, so you can get a lot more information for the detail that you have extracted. A lot of times when you're using JPEG, you end up having banding, or it looks like the pixels are like breaking up into like separate what do you call those noises? It looks like stair-stepping kind of effect. I'll show you guys if we get to that, if we run into that. For now, I'm going to stick to TIFF, and how this works is you're going to type in the name of the object that you want to save out, and not the map type that you save out. Meaning, for example, this would be female base, just that. And then how this works is as soon as I choose my texture map, so what it will do is add an underscore and then the name of the map type. So if it's a normal map, then it's going to do female base underscore normal, or whichever map you're working with. So under the map options, I'm going to choose my normal maps just for now, just to keep it simple. You can see how many different types of maps you can actually extract with this software, whereas ZBrush does not provide you nearly as many maps, but there's ways of kind of manipulating that as well. Right, so the resolution is the map resolution we're going to be exporting out as or to, and I make sure I set both the width and the height of my image to be the same, otherwise you might squash or stretch your actual texture. Then the edge padding or edge bleeding, that's essentially how far the pixels will bleed beyond the UV borders. If your UVs are very tightly packed against each other with a very small space in between, this would be an issue if the pixels were padded too much, that they will actually blend into the other UV panels. So you want to try and avoid that. If they were spaced out quite far, then this would not be much of an issue. Typically, higher resolution images require higher pixel padding or edge padding, if you want to call it that. So on a 2K, it's usually a good idea to start off with something like 8 pixels. And the lower you go, you want to start using 4 and 2 and 1. Okay, so on a 2K, 8 would be a good number. Then the last thing that's worth mentioning is that if your graphics card supports it, then you can use some of the CUDA processors or some of the OpenCL features. If you don't have a fancy graphics card with accelerated CUDA core support, then you will have to stick with a default bucket renderer, which is like a typical software rendering feature. But for the most part, you would always be using the regular standard bucket renderer anyways. So that bucket size is considered as how many pixels you want to save or rendered within one bucket. Now, what is a bucket? That's essentially your CPU core. So if you have a quad core, then you have 4 buckets, meaning you have 4 CPUs, each of them rendering that amount of pixels, whether you have 16 pixels or 32 pixels and so on and so forth. With higher resolution images, there's no point in making the bucket size only 16 pixels per bucket, because you're going to wait for it to render 16 pixels and it's going to keep on rendering hundreds of little buckets over the whole size of the image. So for that case, I typically jump to something like a 512. But if you're rendering with a very low resolution, there's no point to make it 512, because then you'll probably only have one CPU rendering, thus the other ones might be idling. They're not essentially being used for the purpose of baking out the texture. So for the most part, high resolutions, you can start off with something like 512, and then that should suffice. Then the anti-aliasing, this is something that improves the quality of your edges so that they blend nice and even across the pixels. And you want to go for something like a 4x anti-aliasing for this. Right, I think that should be good enough for now. Some of the other stuff in here, like fine details, this is if you're generating extra details using additional maps. We typically don't do this. This is more of a direct gaming workflow. For our case, we don't need too much of that. Some of the other tools, I will talk about these a little bit later. There's a 3D viewer, almost like an actual game mode that you can go in and actually walk around your model to see from all sides what it looks like. So you can definitely use that as well. And for the most part, everything else is kind of just talking about some of the features and who worked on it. There's some examples that you can load up and check. Right, so then just a matter of clicking the generate button. The generate button will pop up. It's going to start rendering. Again, it comes up with that unit size issue. And you can now see each of these buckets are equal to the amount of pixels that's been rendering. So that's 512 by 512 by 512 by 512, and it's going to render that as it goes along. Now, this might take some time depending on the power of your computer. If your computer is quite strong, then you can expect it to Kmap to take approximately a minute, maybe 2 minutes. If you're baking out things like ambient occlusion or curvature maps, you can expect 45 minutes for a single texture to be baked out. They're all calculated with very high resolution detailing, and it really does a great job at calculating the difference between the low poly and the high poly. In my opinion, I've found more success using Xnormal than using Maya's internal its internal normal map generator. Also, ZBrush's normal map generator is not nearly as clean and advanced. Yeah, there's different software for different things, and I've tried a few of them to kind of compare. There is some documentation on the internet where they actually compare which one does a good job with this type of baking and so on and so forth. I'll show you the guys, the actual links to those forum pages where you can go and read it up and kind of get familiar with the different types of map extractions and what they're used for and so on. I think I'll have to pause for this. It's taking a bit of time. Right, so now that it's done, we can see that the map was generated in approximately 194 seconds. How many minutes that is, I'm not gonna... 194 seconds. Perfect, that's the number. Right, so a few issues if we have to look at this. I'm going to close this window. We're pretty much done with the baking, but I can definitely see that there is some areas that came out quite ugly. And I'm going to open up the map on my desktop, and that is under the bakes, if I'm not mistaken. There we go. And if we open this, quickly open this in Photoshop. we can see that areas around the arms where it's kind of wrapping underneath the body, closest to the body, that ended up giving us a really bad projection. Areas over here, some small bugs over there. The fingers came out horrible. You can see how much overlapping is happening here. So that part over there is actually the finger, and then the set of pixels kind of stretching across the length, that is the edge padding. So that's about 8 pixels if I had to go and count them, 1 2 3 4 5 up to there. That should equal to 8. So if these were very neatly packed against each other, then this edge padding might bleed over to another UV border. So that's why you have to be very careful with those kind of things. So the only way for us to really preview this normal map is to actually bring this into Maya and actually have a look at it, what it looks like on the physical 3D model. So what I'm going to do is quickly open up Maya and check our map. I'm going to quickly load the mesh. Just waiting for Maya to respond. I'm going to import. I'm going to go to my desktop, female base LP. And once we have that, I'm going to frame on it. You can see how tiny the model is, and that's why Xnormal was having a difficult time trying to find the best values. Okay, cool. So now that we have the model, I'm going to just soften the edges. You can see the hard edges. So I'd like to soften that. That's going to make the whole model appear to be a lot smoother. So mesh display, I'm going to go to my soften edges. There we go. And then I'm going to create a brand new material, right clicking on the mesh, new material, and then go to just a default blend for now. Once we have the blend assigned, I'm going to go to the bump channel. I'm going to click on the create render node button, and that will bring us to the file node that we associate to that. When the 3D bump or the 2D bump shows there, we need to change the use as from bump to tangent space, and that will load the normal map proper so that Maya reads it successfully. Then I'm going to go back to my desktop under bakes and load in my TIFF file. So once that's loaded, I'm going to click on the sample refresh node just to refresh the texture, and then we need to press 6 to preview the texture on the model. Right, so that did a pretty good job. Now typically where you have UV seams, that is where you're going to have the most common area of notice, where you're going to see the seams and those kind of things. If we were to look at those problematic areas, we can see right there in the arm that turned out quite ugly, some bad projection, or probably areas that the projection missed. So under the fingers, or between the fingers, you can obviously see there's some seams, and then if there was a lot of difference in the baking, then we might see the projection of this finger in between those. So that is also something that we can try and fix using the cage method. But overall, we definitely got a lot of detail. If we were to turn this off, that compared to that definitely feels more detailed. We can see some of the bony landmarks, some of the muscle features. Right. So let's quickly see how we can actually create a cage. So for the cage, what I typically do is I import both the low poly and the high poly into Maya, and depending on the resolution of your high poly, this might take a while and also slow down your viewport quite heavily. So once I have them imported right on top of each other, I usually go and change them, give them their own layers. So I'm going to change this to high poly, going to associate a color to that just to distinguish between them, and then my low poly. This makes it a little bit easier for me to actually select them. And then the low poly I will typically duplicate, and this one I will then inflate so that it encompasses both the high poly and the low poly. So how do we inflate this? Well, we can use the vertices. We can actually select all the vertices on the mesh. Just make sure I have everything selected. And then what I would do is I would go to the edit mesh, and then there should be a feature, if I can find it. I think it's mesh display. It's called transform component, if I can just find it. And transform, I think it might be that one. Yeah. So I'm just going to pull along the Z axis, and that will inflate the low poly until it completely encompasses areas of where the high poly might intersect. Now you don't want to go and bloat this thing like that, for instance. It's quite interesting, but that's definitely not what we're going for. So you typically want to then go and address localized areas, like over here. Maybe grab some of these vertice points and manually move them out just to cover that area a little bit more, because the cage will essentially prevent the high poly to go and project any further than itself, or beyond that depth or range. And this might take a while. Sometimes you might spend an hour kind of tweaking these things. This is all just to prevent the overlapping or weird kind of projections in areas like underneath the arms and so on. We could also use symmetry. So if I turn on the symmetry feature over here, okay, so I turn on symmetry now, so now I can just tweak one side separate, and then the other side will follow along for free. So I just want to pull this out until I don't see any weird overlapping anymore. Yeah. You could definitely use the sculpting tool to help you with this process, absolutely. Yeah. So let's go to face mode. As long as you do not change the physical topology of this mesh, but rather just pull the points out until you've covered those areas, then it shouldn't be a problem. If you were to change the topology, then Xnormal will actually give you a message saying the topology is different from one to the other. In fact, when you bring in the mesh, it immediately gives you that warning saying make sure that the topology did not change. So the more time you spend over here, the less issues you will have later. And after all, you are baking this out to be previewed on all levels. You don't want to have, you know, random shapes poking out, looking like it's just not well projected. You don't want to lose all the work that you've spent on sculpting inside of ZBrush. So what I'm doing here, I'm just selecting the points, and then I'm using, with my move tool, holding down Control and then middle mouse click and drag either to the left or to the right, and that will literally inflate the vertices around that mesh along their own normals. And then together with that, I also add a tiny bit of soft selection. So I'm holding down B, click and drag, and that soft selection will allow me to affect the vertices around that local area as well, instead of me tweaking one vertex at a time. So that helps a lot with speeding up the workflow a bit. Right, so tweaking those like that. It's good. Let's go over here, face selection, inflate those over there, a bit on the head. Ears seem to be good, fingers seem to be good, as long as they don't overlap. There's a bit of overlapping, so you might want to go to the vertices, grab them, and then holding down Control and middle mouse, tweak those until they're more or less like that. There we go, that's good. Right, I think we're pretty much in good place. Maybe one or two more areas. Okay, I think let's give this one a try. So I would then select this mesh, and that's obviously the inflated mesh. I'm going to call this one my cage. I'm going to clear my history, and I'm going to call this one my high poly HP, just for the sake of keeping things nice and tidy, and that's going to be my low poly. Right, so the cage is the only one that I need to export. The other two we already have exported. So I'm just going to select my cage, go to File, Export Selection, make sure you have your OBJ file format selected, and then I'm going to export this as female base, and then set this to low poly cage, LP cage. Right, so then lastly we go back to Xnormal. Just minimize this guy and move it off to the side. And in my low poly definition, not the high poly, because the high poly stays static, that doesn't change at all. It's only the low poly that will have the mesh cage. So then we're going to right click in here, and then we're going to say browse for external cage file. So when you're right clicking and say browse for external cage, it will then give you the same kind of window. You're going to search for that low poly cage. There we go. Load that in. If you specify an external cage file, please make sure that the selected mesh is absolutely the same topology. So that was the warning message that I was talking about. So we only changed the positions of the vertices. We did not physically weld or insert edge loop or any extrusions of sorts. We physically just moved the points. Right, so that loads in, and that will do a pretty good job for us for the most part. There might still be some issues in certain situations, and you have to find where the problem is coming from. Is it because the cage was not properly fitted to the actual high poly and low poly to encompass both, or is it a case of maybe some of the body parts are too close to each other? And that will then bring me to another point where we can use blockers. So we will see what this result yields, and then I will do an additional part where I will add blockers in between areas of like the fingers, underneath the arm, maybe inside the mouth, you know, all those kind of things. Any geometry that might be overlapping is prone to having weird or bad projections. So just by loading the poly cage, let's see what this provides us now. I'm going to change the file name just so that we can compare the two, and let's call this female base 02 TIFF, and then generate. Same little message popping up, and we wait. So after the bake, this came out pretty nice. We have some small errors still in some areas, but for the most part I think this did a much better job than the previous one. So let's quickly compare these two side by side. So this is my original. I'm going to shrink this one down a bit. Just look at it overall, and then I'm going to grab the new one, Bakes, and this is going to be base 02. There we go. Let's pull this one over here, and then this one over here. So you can see in the areas around the fingers, that's definitely way better. So do that, and then also zoom in over here. There's a lot less weird kind of overlapping and pixels kind of stretching and so on. Even though we still have the same edge padding, the colors are a lot more softer and more within the realm of the actual normal map. So around the, let's have a look, areas over here on the body, you can see that's a lot cleaner, almost no issues. Underneath the arms, that came out pretty nice. Let's have a look at the face. If we have some weird issues, you can see the ears ended up giving us much better projection. The mouth, any border edges seem to be a lot more cleaner. So in general, I would say that just using the cage makes a massive difference in the quality of your normal map. Now you might still get some issues in some areas, so you could either go and like fix those on the cage and try to find a better projection. You can see around here on the inside of the mouth that turned out to receive some of the projections from above, or that's the foot, I think. I'm not too sure. I think that might be the foot. Let's have a look. General, the ears looks quite nice. Right, so one last thing that I would like to just kind of point out and mention is using blockers, and those are ray blockers. Those are typically just flat planes that you can actually put in between parts of meshes that might typically overlap. So areas of the fingers, areas between the thighs or the legs, those are areas where you might want to put in an actual blocker, so that when the ray hits the blocker, it actually prevents the rays from being shot and calculated on the other side of the leg. Thus, any weird mirrored kind of reflection projections are avoided completely. So the way that I do this is I would go back to my Maya document, and then I would go and create just a simple flat plane, nothing special. You can even reduce the subdivisions to pretty much 1-to-1, and then you can move these into position, rotate them, and then move them so that the projection is not applied between these legs. So I'm going to go to my front view for easy placement. I'm going to snap that to the center, get that as close as possible to the mesh, and I will extend the actual edges or the vertices on my blocker all the way to the feet. Okay, that would be one blocker. I'm going to select that. I'm going to duplicate it. I'm going to move it towards the hands. I'm going to make that smaller. And I'm going to position that between each finger. So for now I'm going to hide my cage. I'm going to put that in a separate layer so that I can look at my original and have more of a proper representation of the space between the fingers. I'm going to frame on that. And yes, again, this does take a bit of time. So you would just go and rotate these guys until they fit within the space of the fingers. Something like that would be good. And then I would Control D, and then I would put it to object space, move that over. You could add a bit of bending to them if you really wanted to, if you want to add additional subdivisions for the polycards, just to allow it to bend a little bit better in between the fingers. In some cases, just the flat plane itself might be a bit difficult to fit between the parts that you're trying to avoid the projection to occur. So something like that, Control D again, and then just one big one so that the thumb does not project over that area. Something like that. Right, so I'm going to select all these guys. This one, and this one. And then I'm going to duplicate this guy. Or rather, let's first freeze transform it. Let's clean our channels. I'm going to group it. I'm going to duplicate the group. And then I'm going to scale it -1 along the x-axis. That will place another set on the opposite side for the other hand. And then areas inside the mouth, not that I think we will be viewing the inside of the mouth that much at all, but you would then create a polygon card that would fit right in between the lips to essentially prevent that. If you did a good job with your actual cage model that essentially prevents the rays being shot through from one lip to another, then you actually don't need to have a blocker in those areas. But usually fingers and between the thighs, maybe if you have overlapping on the tail, you would, if the character had a tail or even wings, you would do the same kind of approach. I think I will add one additional set of these between the actual arms. Control D, move that more or less over there. Let's scale this up. And then I would put these right at the intersection between the back of the character and the arms itself. Something like that should be good. And then same thing, I'm going to take this guy, I'm going to freeze transform it, modify freeze transform. I'm going to group it, I'm going to duplicate the group, and I would scale that negatively along the x-axis. And then finally we can take all the polycards and then we can export all those as the blockers. Export selection, and let's call these blockers female character blockers. Right, I'm going to hit accept, and I can then go back to my Xnormal software. I'm going to minimize Photoshop, and then under the low poly we can right click over here, and then where it says browse for blockers, we're going to click on that, and then we're going to choose the blockers. Female character blockers, open that, and then pretty much run through the same process of just generating it. Actually, just before we do that, I'm going to terminate that, close, and give it a different name, like number 3, so that we can compare again. Right, generate and wait. Right, so the last map has been extracted, and I think we have a pretty good looking result. Let's open that up in Photoshop. File open, and it's going to be version 3 this time. And if we have a look, we can definitely see that we have reduced a lot of overlapping or weird stretching, anything that could possibly go wrong in between the fingers. That seems to have cleared out a lot more. Let's see in version 2 if we still have a few issues over here. Maybe there in the hand over there should be a tiny bit of an issue. On the edge of one of the fingers, and then with this one, that's still there, so that's the bounding box that we still need to fix or address. But overall, I think we have a pretty successful projection. We don't have any weird kind of projections like we had in the first one with all these random bits unprojected. So what's actually happening here is because of the bounding box. In fact, let me quickly draw it out. If we were to create a new layer and then fill that with, let's say, black for now, or white, doesn't matter. If we were to compare the low poly, let's say this is my low poly box, and then we have a high poly mesh that's more or less in the same kind of position with a slight, in fact, let me do it with a red color so we can actually see the difference in height information and variation over here, with a round curvature over there, something like that. Right, so the black would be our original low poly mesh, and the red would essentially refer to our high definition. So red, let's reduce the actual brush size so we can write this out properly. Red equals high poly, and then the black would refer to the low poly. Let's write out that, there we go, low poly. So what the cage is doing, I'm going to make the cage a blue color, is essentially it takes the low poly resolution. It has to be the same topology from the initial low poly, and you're essentially inflating it to just about the average height and or position of that will encompass our high poly. Okay, you can't change the topology, but you can move the points around. So what this does is then it tells the ray distance calculator, use the average values of the cage difference, and then anything that's within the cage itself will then project the difference from there all the way to there, and that will then propagate to the final texture. So that's essentially what's happening. So if the cage had to slice through a part like that, for instance, any part that was not inside of the bounding box of the cage would essentially be void. Let's make the brush a little bit bigger. Erase, oops, that's not what I want. All those parts would essentially be kind of clamped off completely. So again, let's go to maybe, yes, exactly. So let's go to more of like an orangey color, and then brush smaller. So all this information from there to there would be clipped off completely. Think of it as you were to slice off that piece of geometry, all the physical geometry difference between this and up to that point where the mesh of the cage intersects with the high poly would then be clipped completely off, like it's been sliced off, and that will essentially project as a flat plane, and that causes the normals to change its colors, thus you're not getting a clean projection. So what you want to do then is just change the overall profile of the bounding box so that you're essentially capturing all the details from the high poly. And that you'll have to do manually by grabbing some of the vertices and pull them out until your high poly is perfectly within the envelope of the cage, if I can call it that. Right, so that's more or less the theory behind this whole projection thing and how to make it more successful. And then parts of a mesh that might be, let's say, again, I'm going to take the example of fingers. Let's make that black, or just I'm going to make two cylinders next to each other. Think of these as fingers. So essentially a ray will be shot towards and or away from, depending on the settings that you say, and then if it looks inside the mesh and it finds the actual high poly mesh, let's say we have some overlap and different variation and something like that, what this does is then it tries to calculate the difference between these, and if you don't have an actual cage, the blue one, these rays will be kept they will essentially keep projecting right through the mesh and maybe hit the back side. So any information that's been sampled on the one side will keep passing through, and then when it hits another surface, it will then propagate that information as part of the texture onto another part of the mesh, almost like a reflection image of that finger or that physical geometry. Thus, that's why we need the cage, to essentially prevent these projections from happening. So then another solution would then be using something like cards, blockers, let's say green, and that would be a blocker. Okay, so a blocker is just literally a plane that you put right in between these guys, and then when that ray is shot and it hits the actual blocker, it will stop, terminate the calculation, and not have any weird projections going beyond that edge. Thus, our projections are a lot cleaner. So you can definitely make use of that for your projects to make sure that you have the best possible projection. Okay, I think that's more or less the information that I wanted to get across using the Xnormals. I will do another video where I specifically talk about polypainting and how to bake out those kind of map details using Xnormals. But yeah, I think we've covered what I wanted to do.